All right, folks, we want our patty paper to look like the notes that we're taking, right? So we want a segment, and then this dashed line is going to be a fold. It's going to be a valley fold, and it's going to be perpendicular. It's not just at some random angle. So don't fold anything quite yet, but I do want you to draw a segment on there. Okay, so here's what we're going to do first. We're going to go like this. We're going to kind of try to make it look a little bit like exactly like our nose. I think it was going kind of like that angle. And we're going to put points at the ends, and let's put capital letters on those points. Let's put A and B. We capitalize the letters for points. Then what I want you to do is you're going to pick up this area of the paper and you're going to put B right on top of A. And you can see through the wax paper. Yeah, you can see through it in the camera too. I was a little worried you wouldn't be able to see through it in the camera. But we're trying to get the point B right on the point A, and then the line's going to be right on top of the other line, the segment. And then you're going to make a nice crease. And I want you to use a fingernail because this is wax paper, so the wax will kind of build up of where you make that crease. Okay. And now let's unfold it and let's take a look and see what it looks like. All right. So my fingernail did create like a little bit of a wax buildup right there, but you can clearly see, and I want you to darken it in with your pencil, where the perpendicular bisector is. This segment that I'm highlighting right now is a perpendicular bisector. So let's mark what that means. We've got a perpendicular or right angle right here. So that's 90 degrees. Okay, 90 degrees, put that right there. And then this segment here, this new, like we just created that segment. Let's put a letter M for midpoint. This is the midpoint right here. It means this segment here is equal to that segment over there. So what you can do to make that really clear to everybody is you can put a little tick mark there and a little tick mark here. So the fact that there's one tick mark here and one tick mark here means this segment is equal to that segment. All right. Now we're going to do some investigating. What does that mean in addition to having a right angle and this segment equal to that segment? Well, if I know this is the perpendicular bisector, let's see what happens if I pick a random point up here. And let's call that point C. Okay. Doesn't matter where you put C. You could put it over here if you want. And then I'm going to measure how far C is from the endpoints. I want to see if there's some situation here, some truth. It looks like 6 centimeters from where I put it, right? Can you see that? 6 centimeters. I'll turn the ruler over. The numbers are upside down. So we've got 6 centimeters, don't we? Okay. And now let's go the other way. So, let's put a little segment there. Okay. So we've got segment CA. And then I'm going to go to the other side and I'm going to measure this way. And I've got, where is it? Right there. 6 segments, or six centimeters right here. So let's put that on there. 6 centimeters and 6 centimeters. And then let's put 2 tick marks on those sides saying these 2 sides are equal. So we'd have an isosceles triangle right there, right? Let's try another one. Let's pick one like closer to the midpoint, but down here, and let's call it D. And then let's measure that right there. So I've got a little bit less, right, than I had before because I'm closer to the midpoint. So we've got, looks like 5 centimeters now. So let's mark that in. And let's mark this segment over here. That looks like 5 centimeters also. Mark that there. Whoops, got off there a little bit. And let's put 3 tick marks on this one. 1, 2, 3. 1, 2, 3. And we said that's 5 centimeters. So I'm hoping you're saying, you know what? You can put the point anywhere on the perpendicular bisector, and the distance from that point to the endpoints is going to be the same on either side of the perpendicular bisector. So let's talk a little notation for a second. We said this segment is 6 long. You could do this. You could say AC with nothing over the top equals 6 centimeters. That's one way of saying the segment is 6 centimeters. If you want to say this segment right here, you put AC with a bar over the top. Okay, that's the notation for segment. So I want you to add that to your notes. All right. Let's see. I think that's about it. I hope you could see everything on my paper clearly. We're going to transfer all that information over to our notes. Okay. So that means that you're going to put, a point up here. You're going to draw over to there. You're going to draw over to here to the endpoints. You're going to label these endpoints A and B and all that kind of stuff. Okay. So we talked about segments. We talked about points, the correct notation. We talked about what a perpendicular bisector is. Okay. The word bisector is missing here. I'm going to have to put that in there. Perpendicular bisector. The perpendicular bisector theorem says that if we have a perpendicular bisector, then any point on this dashed perpendicular bisector would be equidistant to the two endpoints. So that point is equidistant from this endpoint, and that point was equidistant to that endpoint. What it means when it says the converse of the perpendicular bisector theorem, that means that if we have a point that's on a line and it's equidistant from the two endpoints, that point must be on the perpendicular bisector. So if we could find like one point here and we know it's on the perpendicular bisector, and then we find another point over here and it's also on the perpendicular bisector, then if you connect those 2 points together, you would have the perpendicular bisector. So I know I've said that word a lot, perpendicular bisector, those words, but they're important. That's what we're trying to use today. And we're going to fill in our notes in class. So thanks for watching my video.